Hello, once again, this is Mr. Wakefield. We're going to be looking at section 6.2 at this time. Now, we talked about in the last section not only about putting a fraction in lowest terms, but also multiplying and dividing fractions. So naturally now, the next thing that you'd imagine would be adding and subtracting fractions. And now that since we've already done multiplying and dividing. But as it turns out, you cannot add and subtract fractions unless you have the same denominator. Okay, same denominator. But we can't just pick any denominator we want to be that same denominator. We have to, especially when we once again get into these polynomials that have more than one term in it and that kind of thing. If you pick a denominator just that's any common denominator as opposed to getting as you see here, the least common denominator. If you just pick any common denominator, what you're going to end up getting is an answer that oftentimes is too difficult or impossible to get into lowest terms. And just like the previous problems in 6.1, you need to get your answers in lowest terms when you're adding and subtracting as well. So we'll get into how to add and subtract here in a little bit, but first of all, we need to know how to find what the least common denominator is so that we can then use that knowledge when we get to the problems where we actually have to add and subtract. Now, what I want you to do right now is as you look at these problems down here where it says find the LCD, least common denominator, is I want you to pretend that all of these polynomials you see right here are denominators. Since we're just trying to find the least common denominator right now, I didn't think it would be useful to write down an entire fraction for each one of these. So I just want you to imagine, I just wrote down the denominators, and so that's why these don't look like fractions. All right, but I want you to imagine that each one of these things is on the bottom of a fraction, and we need to find the least common denominator of each one of them. All right, so as was the case in the previous section, so it is here. If each one of your denominators is just a single term, the way in which you calculate the LCD is different as compared to if one or more of your denominators has more than one term. We'll get to that in just a moment. Let's look at problem A first. When you have single terms for all of your denominators, you first of all start out with the coefficients, right there, and you have to find the least common multiple of those. Well, okay, well, what does that mean? Well, multiples, you guys, they're in many ways the opposite of factors. Multiples are bigger. All right, multiples are numbers that you could divide by the number that they gave you evenly. All right, so for example, 30 is a multiple of 15 because 30 divided by 15 is it divides evenly. It's equal to 2. 48 would be a multiple of 24 for the same reason. It divides evenly. How do we find these multiples, though? You could, for example, the easiest way to do it is just to take, and you can use your calculator for this, 24 times 1, 24 times 2, 24 times 3, and it just keeps going after that. That's how you can find the multiples. Instead of finding the multiples of each number, though, you could just do it for the biggest number, and you can keep on going until you find a number that also fits into this box right here for the smaller number. Because if it fits into that box, that means it's a multiple of 15 as well, and therefore it's a multiple of both. It's a common multiple. So, but if I start out with the smallest multiple of 24 and I work my way up, the first one that works also for the 15 will not only be a common multiple, but it would be the least common multiple. So that's what you do. You take the biggest number, 24, the biggest out of these two. Out of the coefficients, you take the biggest one. You keep on listing out the multiples, going bigger each time until you find the first one that also works for the other number. And so 24 divided by 15, no, that doesn't divide evenly. Again, use your calculator if you're not sure. 48 divided by 15, no, that doesn't divide evenly. Same thing with 72. Same thing with 96. But the next one, 120, that one does divide evenly into 15, okay, or by 15. It is exactly equal to, as your calculator will confirm, it is exactly equal to 8. And so therefore this must be the least common multiple. But that is not your final answer. It's part of your final answer though. What we do is we put the 120 in there. But when you have single term denominators, you also have to look at the variables. And this is exactly the opposite of GCF, but since multiples are numbers that are bigger than the numbers that you have, they get bigger, it would make sense that instead of taking the smallest exponent like we did with GCF, we are now going to take the biggest exponent. All right, and as you can see, between x squared and x to the first, the smallest exponent is x to the second. Or, I'm sorry, the biggest exponent. I'm sorry, I was thinking of GCF there for a moment. The biggest exponent is x to the second. All right, so for least common multiple, or least common denominator, in other words, you take the biggest exponent. GCF, you take the smallest exponent. Again, this is just when it's a single term. All right, for each one of your denominators. What happens, though, when your denominators are more than one term? Well, just like in the last section, you have to factor everything first. We're not going to be doing any canceling here in these problems, but we are going to have to factor and identify our factors with the red and green pen again here. Let's do that. So if I factor this first one here, I get y minus 2 and y plus 2. Again, that's two red ones right there, like that. And then the other one, notice that that is already in factored form. When you have a term times a bracket, that's already in a factored form. So as I mentioned in the previous section, when that happens, you just have to check to make sure that the bracket can't be factored any further. All right, and it can't be because it has two terms inside the bracket with y to the first power, so that means it's already prime. Okay, so what we have here, you guys, is we have I've factored everything that I can. I have identified my factors, and here's how you do the LCD. You look at the green ones separately from the red ones, just like you did before. But the difference here is we're not going to be doing any canceling. The way it works is it says up here in the step 2, it says find the least common multiple of the single term factors. The single term factors are the green ones, all right, as we talked about before. The multiple term factors, which will be in step 3 coming up here in a moment, that will be the red ones. So starting out with the green ones, if you have only one single term factor, your LCM, or your least common multiple of your single term factors, would then just be that. There's nothing to compare that single green one. In other words, there's not another green one to compare that one green one that you have to that. So when you have just a single green one, just bring that down into the answer. If there was more than one green one, then we would have to do the same thing that we did over here. Okay, we'll see that coming up here. Now, when we get to the last part here, the last step, it says list out each of the what? Very key word here. Different multiple term factors. Please notice, you guys, we have 3 red ones, right? But there's only 2 different red ones, y minus 2 and y plus 2. Y plus 2 occurs twice, and so there's only 2 different ones, y minus 2 and y plus 2. So all you got to do is just take those multiple term factors and put them in there. Just put all the different ones in there. Do not put all 3 of them in there. All right, you're supposed to put all the different ones in there. There's an exception to that we'll see in the next problem, and I'll show you why that doesn't apply here when we get done with the next problem. But normally, you just put all of the different ones in the answer along with whatever you got from the step 2 here with the single term factors. Okay, and that's it. Okay. Now, in the third one here, problem C, let's go ahead and factor it again. Since we have more than one term in our denominators, unlike the first problem, you have to factor everything. And I'm doing the Berry method here on both of these. All right. Just did the Berry method. I'm sorry, I apologize. I did the Berry method on the second one. The first one was just the a squared minus b squared formula. All right, again, we've seen that before, so that's why I just kind of went through it quickly there. As always, let me know if you're struggling at all with your factoring. So that gives us a total of 4 red ones, doesn't it? Each one has 2 red ones in it. Notice that there's no green one this time. If there's no green one, you can go ahead and skip the second step up here and jump right down to the third step, which is where you deal with the red ones. Notice that we have 4 red ones, but there's only 2 different red ones, isn't there? X minus 5 and X plus 5. There's no other ones besides those 2. So we put those 2 in the answer here. X plus 5 and X minus 5. It doesn't matter what order you put that in. But this is where there's a special exception here. Theoretically, it says if a multiple term factor, in other words a red one, appears more than once in a denominator, in the same denominator, then that's going to be our special exception. Check this out. Notice that X minus 5 here appears once. X minus 5 appears once in this denominator, right? But doesn't it appear twice here in this one? See how X minus 5 appears twice here? But it appears once there? Okay, so if it appears more than once in the same denominator, not for the whole problem, but just in that same denominator, if it appears more than once in the same place, then that's different. Then you have to put it in the answer twice. Okay, it says listed out the greatest number of times it appears in a denominator. So in other words, if it appears once and twice, the greatest number of times it appears is twice. Once and twice, you put it in the answer twice. Okay, so how does that make it different from the other red ones that we've looked at so far? Well, look at X plus 5 right here. It appears once here and none here. What's the greatest number of times it appeared? Let me say it again. Once here, X plus 5, none here for X plus 5. What's the greatest number of times it appeared? It appeared once, right? That's the greatest number, between once and none. So that's why I put it in the answer, once. Same thing over here. Y minus 2 appears once in the first one, none in the second one. What's the greatest? Once. Y plus 2 appears once in the first one, once in the second one. Once and once. What's the greatest? Once. And that's why it appears in the answer, once. So it all depends on the greatest number of times that it appears in any of your denominators. Okay. All right, I'm going to actually do problem number 3 because that, even though it's numbered, just because it has a little bit of a different look to it. There we go. Actually, you know what? I'll keep zoomed in so you can see it better down here. All right, there we go. So let me factor that. Both of these have a GCF. And then after you factor the GCF, both of them have prime polynomials. Both of those brackets are prime. They don't break down to 2 brackets like we oftentimes see that happen. That doesn't happen here. So we got a couple of green ones and a couple of red ones. A couple of green ones and a couple of red ones. What do we do now? Well, after we factor everything, step 2 says to find the LCM of 5 and 10. Again, you figure it out the same way that you figured out this one up here. Same exact way, guys. All right. So what's the LCM of 5 and 10? Again, you start out with the bigger number 10. You list out its you list out its multiples until you find one that works for 5. In other words, since 10 is a bigger number, all right, you list that out until you find what works for the smaller number, just like we did with 15 and 24 in problem A up above. Okay, starting out with 10, does that work? Actually, it does. Okay, so you don't even need to go any further than 10. I just wanted to make that list just for practice right there so you could see it. But 10 is the first one that works. Remember, you got to take the smallest one, the least common multiple. So check the 10, and if that doesn't work, then you check the 20 and then the 30. But 10 worked. And so there you go. Now, notice that 5 and 10 don't have any variables in it. Okay, remember when you're doing this method here, like we did in problem A, it's just for the green ones. Okay, so don't creep over here into the red ones and try to do anything with that. That's a whole separate thing. We're just doing it for 5 and 10. So there's no variables in the green ones. So 10 is the only thing that you get out of 5 and 10. So then we go over to the third step where we list out all of the what? All of the different red ones. All the different ones. Okay. And the only time that we ever put one of those red ones in the answer more than once is if it appears more than once in the same denominator, like we saw in problem C. That doesn't happen here, does it? You don't have the same red one appearing in the same denominator more than once. So unless that happens, you're just going to simply put all of the different red ones in your answer, and that's all you got to do. All right. Okay. So let's go ahead and try problems 1 and 2 right now. Please go ahead and do that. And then, of course, as usual, go ahead and hit the play button when you're done, and we'll take a look at the answers. All right, let's take a look at problems 1 and 2 here. If you factor out number 1, the two denominators here, this is what you get. You just simply get 4 red ones total here. And notice, though, that because there's just red ones, you can skip the green step. All right, step 2 of the LCM process that you have at the top of the page there. You go down to the last step, step 3, and again it says list out all of the different red ones. And why is it that I only listed out each one of those one time each and that's it? It's because that's what you're supposed to do unless one of those red ones appears more than once in the same denominator. Please notice, x minus 4, yes, that did appear twice total, but it never appeared more than once in the same denominator. It appeared once here and once here. So what's the greatest if it's once and once? It's once, and that's why you put it in the answer once. All right. Conversely, if you look at problem number 2, let me move over. If we factor that, that's a little bit different here because you got a red one that appears, the same red one appears twice in the same denominator, similar to problem C right above here. All right, and so we'll talk about how that works again. So you've got 4 red ones total once again. This time there's only 2 different ones, x plus 7 and x minus 4. However, the reason why I put x minus 4 into the answer twice is because it appeared what? It appeared twice in one of the denominators, and it appeared once in the other one. And so between twice and once, what's the biggest? Twice. And that's why you put it in the answer twice. All right, x plus 7, it appeared once here and none in the other one. So the biggest between once and none is once. And that's why x plus 7 appears in the answer just once. All right, so that's LCD, you guys. That's really going to be important for us to understand as we move on into adding and subtracting fractions. All right, now down here in regards to adding and subtracting fractions, now that we know how to find the LCD, knowing that we need an LCD in order to add and subtract fractions, let's go ahead and use our knowledge that we just attained in order to find out the LCD of these 2 denominators right here, and then I'll talk about how to use that. As we found out just in the top part of this page, you need to factor your denominators in order to find the LCD when your denominators have more than one term in it. So I'm going to do that right now. This one is going to be, again, the Berry method tells us that it's going to be x plus 4 and x minus 2. This one would be x minus 2 and x minus 1. Again, just doing the same thing as we always do with the Berry method there to figure that out. It gives me a total of 4 different 4 factors total, but how many different factors do you have there? We have a total of 3 different ones, don't we? The x minus 2 appears twice there. It doesn't matter what order you put them in, as long as they're all being multiplied. Okay, the order in which things being multiplied are written is not important because multiplication, the order can be switched around. just like 3 times 7 is equal to 7 times 3. Okay, same thing here with these three things being multiplied. So now that we know that that's the LCD, go ahead and let's write out this problem. I usually like to write it in a vertical format here, going down like this. Put your denominators in their factored form that you already discovered just now, so that you can, it's just easier to figure out how to transform your denominator in so that it will be equal to the LCD. It's easier to do all of that if you have already put the denominators in their factored form that we just found out. Okay. So pull out a different pen here just to give it a different color here. But notice that, and let me write down the LCD over here too. Remember, we want our denominators to become this: x plus 4, x minus 2, and x minus 1. Let me write that down for each one of these. Okay. So now, notice please that each denominator already has 2 red ones, right? The LCD has 3 red ones. And in fact, not only does it have 3 red ones, but 2 out of those 3 red ones are already sitting here in the current denominator that I have. So wouldn't it make logical sense that in order to take this right here and make it equal to this one, wouldn't it make sense to just multiply that denominator by the missing one there that is not in the LCD? Or I mean that is not in the current denominator, but it is in the LCD. Notice that x minus 1 is the one red one that's not in the current denominator. All right. So by multiplying by that, it will now be equal to this, isn't it? All right. And you do need to multiply the top and the bottom by the same thing. You can't add something or subtract something. Okay. It has to be multiplication, and it does have to be the same thing on both the top and the bottom here. Okay. So I'm going to have to multiply the top by that as well. All right. And so, by the way, as I consider that now, I do need to actually multiply this out, meaning I need to clear out the parentheses this time. I know we didn't do that on some of those problems before in the previous section, but we do need to do that here because we're going to be adding the numerators together here eventually, and so we can't have any brackets getting in the way of that. So I need to distribute that out. I get 7x squared minus 7x. All right. And again, make sure to put that in brackets, not just because the missing thing was a bracket over here, x minus 1, but also because anytime you have more than one term and you're multiplying it by something, that whole thing, x minus 1, is being multiplied by something, you got to bracket x minus 1 in that case. All right. What is the, we have the same thing going on down here. We have x minus 2 and x minus 1. And the LCD, we also have x minus 2 and x minus 1, but we also have x plus 4. So wouldn't it make logical sense to multiply by x plus 4 in order to get it equal to that? Remember, the order doesn't matter here. All right. I know the x plus 4 is last here and it's first here. It doesn't matter because these three things are all being multiplied together. So they could be, the 3 brackets could be in any order and it would still be the same thing as this. So just multiply by the missing red one there and you're going to be good. All right. So we got to multiply the top by the same thing. Again, you got to clear out the parentheses here so that you can add the numerators together here in just a moment. And so speaking of that, you guys, when you get the denominators equal to each other, and you can't do it before that, absolutely not. But once the denominators are equal to each other, you are allowed to add the numerators. Okay, now how does that work? Well, it's kind of like this. Remember at the beginning of chapter 5, we had those problems where we had a bracket plus a bracket. Okay, I know the numerators don't have brackets around them, but we are supposed to add the entire numerator plus the entire other numerator. So it's kind of like this where each bracket is like a numerator. All right, so Just like bracket plus bracket, what did we do? We just simply combine like terms. It's the same thing here. Numerator plus numerator, we do exactly the same thing. We combine like terms, like this. And please put it in descending order of degree, all right? Not saying that that's always necessary, but that never seems to fail as far as getting us here to the next step, the thing that we're going to need to do next. Put it in descending order of degree. In other words, x to the second, x to the first, and then the constant. All right. And then what you do, first of all, before I mention that, remember when you add and subtract fractions together, the LCD, or the denominator, which is the LCD, but the denominator has to be the same, and then it stays the same. It has to be the same, and then it stays the same. Just wanted to say that more than once just to make sure. So once you have done this here, where you've combined the two fractions into one by adding the numerators and keeping the denominator the same, you then take that and you put it in lowest terms. Sometimes it'll already be in lowest terms and sometimes not, but we got to at least try. Now, if you do your LCD in the normal way that I show you here, the LCD should already be completely factored. So, and that's part of doing the lowest terms, is to factor the top and the bottom. So that's already been done for us. We just need to factor the top. That looks like a Berry method situation, doesn't it? 7 times 12. 7 times 12 is 84. And then the middle has to be -4 right there. As it turns out, you guys, there are no two numbers that work for that. You can try, but there isn't any. And so that means that this thing is prime, since the GCF was also equal to 1. Okay, and when it's prime, it's just one big red one there. I mentioned that because there's nothing you can cancel there, is there? Remember, you can't cancel part of a red one. Okay, the only way I can cancel one of these red ones is if there's another one above or below it that's either exactly the same or has that same term opposite sign thing going on that we talked about in the last chapter. Not true here, right? So you tried to put it in lowest terms, but it's already in lowest terms, and so that was the last step. Okay, so that is how you add fractions. The way you subtract fractions is exactly the same, except for one additional step. All right, let's take a look at that right now. Okay, so problem B. Again, remember you want to, I'm going to set it up in the vertical format here. I'm also going to factor my denominators at the same time so that I can then figure out what the LCD is. If I factor that first denominator right there, is going to be x plus 5 and x minus 2. Again, that's a Berry method. The second denominator, though, as you can see there, is already factored. It's prime, in other words. All right, you can't factor it, in other words. All right, x minus 2 is prime. So what we got here is we have a single red one here since it's prime. These two here are a couple of red ones. We're going to be subtracting this time. And so what is the LCD? Well, you can see here we got 3 red ones total. No green ones, but 3 red ones. But there's only 2 different ones, isn't there? X minus 5 and x plus 5 and x minus 2. And none of them are going to go into the LCD more than once. Okay, they don't fit the description of that type of situation that we talked about earlier, where sometimes you do have the same red one going into the LCD more than once. That doesn't happen here. So that is the LCD. So we write it down twice here, once for each denominator, and then our goal, once again, is to get each denominator to make it look like this one right here. Now, here's the good news. The first denominator that we currently have already does look like that. It's exactly the same. So as they say, if it ain't broken, you don't fix it, right? Okay, this thing already has the LCD in it, so don't mess with it, all right? It already looks exactly how we want it to look. It has the LCD in it. This one, though, kind of similar to what we were talking about earlier. We have two red ones in the LCD. One of those two is already sitting here. And so wouldn't it make sense to multiply by the other one to get it equal to that? I know there's no bracket around the x minus 2, but whenever you have a denominator with more than one term in it, it's as if there is a bracket, an invisible bracket around the whole thing, because it's implied that when you multiply a denominator by something, you're going to multiply the whole thing. So it's like there's an invisible bracket there. So it is truly the same thing as this. It's just in a different order, but that's okay. We know that when you have two brackets in a different order, they're still the same thing as long as they're the same two brackets that you're dealing with. Okay, so we got to multiply this one by x plus 5 as well. In fact, you can put those, you don't have to, but you can put those brackets around this right here just to remind you that, yeah, we're going to multiply the whole denominator and the whole numerator by x plus 5. And that is a good reminder for us because that completely changes this right here. All right, if it was written like this, if we wrote it like this right here, which a lot of students forget that this is not exactly what's going on, but there is a bracket around. Sorry, that fell off the screen there. Let me fix that. So if you write it like this, it looks like you're just going to be multiplying -7 by x plus 5. That's why you have to at least think of this as having a bracket around it. All right. Again, when it's your entire denominator, right, or when it's your entire numerator right there, it's already implied that there is an invisible bracket around it. But I wouldn't want you to think that there wasn't a bracket there. So I put the bracket there just as an added reminder to make sure that we treat it as if there's a bracket there. Okay. It's not like this up here. It's got to be at least thought of as a bracket there. But I'll put I'll actually physically write the bracket there. Like I said, it makes it easier. So the first numerator did not change because the denominator didn't change. All right. If you don't multiply the bottom by anything, the top stays the same as well. But here, what is this right here? Well, as you guys know from section 5.2, all right, when you got a bracket times a bracket and both brackets have more than one term in it, all right, you got to multiply it out. Starting out with the first term over here, distribute that through the second bracket, and then you do that with the other term here as well. Same thing here because both of these brackets have two terms in it. Same thing. If I multiply this out, I'm going to get 4 terms here in my answer, just like I did in that example I just showed you from 5.2, and it looks like this. Okay? Now, so we're ready to subtract, but here's where this is the one thing that is different from the first problem as far as the process is concerned. Okay, remember I said in the first problem when you add a numerator plus a numerator, it's similar to when you have a bracket plus a bracket. Well, likewise, when you have a numerator minus a numerator, it's similar to when you have a bracket minus a bracket from back in 5.1. All right, it's similar to that. And that's so important because what did we talk about when we did bracket minus bracket? We talked about making the second bracket have all of its signs change, all of them, not just the first one, but all of them. First bracket stays the same, second bracket changes all of its signs. Okay, let me say that one more time. First bracket stays the same, second bracket changes all of its signs. So likewise, the first numerator is going to stay the same, and the second numerator is going to change all of its signs. Okay. And so, this becomes a minus then. This becomes a minus as well. So in other words, if you have positive in front of a term, it becomes negative in front of that term. If you've got negative in front of a term, that becomes positive now. Okay, so change signs before what? Change signs before combining like terms. just like we did when we did bracket minus bracket back in section 5.1. You got to change the signs prior to combining like terms. So I did that. By the way, just a reminder here, you guys, when you multiply, don't distribute that negative. Even if there was just a single term here, because oftentimes we do distribute a negative with a single term. Even in that case, you don't do that because we are not ready. This is meant to be a subtraction symbol here. And so we want to make sure that the multiplication gets done without that, and then you change the signs, all right? Because the minus sign here means that you change the sign. So if you were to distribute the negative and then change signs, all right, that would be like the minus sign doing its work twice. It's not supposed to do its work twice. So you might be thinking, well, why don't I just distribute it and then not change the signs? All right. Well, you can't do that either because sometimes that can be confusing depending on how it sets up as far as what are you supposed to distribute the minus sign to. All right. So the best thing to do then when you subtract fractions is to leave this minus sign alone. Don't distribute it when you multiply out this part right here, the numerator that's being subtracted times whatever you're multiplying it by. Just multiply that out without the minus getting included in that. And then change signs after that. That's what the minus sign is telling you to do, is just to change the signs after you've done the multiplication. Okay. So combining like terms now, just like we did when we did bracket minus bracket, you combine like terms after you change signs. What do we get? Well, the x squareds are going to cancel. And again, put it in descending order here from highest degree to lowest degree. 2x and then minus 4. So put the x to the first term before the 4, which is degree 0 term. All right. And that should be fine for the next step here. The denominator again stays the same. And then what's that last thing that I got to do, you guys, when we have once we get it down to just a single fraction down here, and I've already subtracted the numerators. All right, what is the last thing I need to do? I need to put it in lowest terms, right? The denominator, like I said, should already be in factored form, so you don't need to factor that again. Just identify your factors right there. We got a couple of red ones right there. All right, and the top, though, if I factor that, it's going to be 2 bracket x minus 2, which is a green one and a red one. Based on the reds and the greens right there, what can I cancel here? I can cancel x minus 2 and x minus 2, can't I? So what would be my final answer then? 2 over x plus 5. All right, so that's how you add and subtract fractions. All right. Don't forget when you're subtracting to change those signs of the denominator or of the numerator rather, that's being subtracted, not this one up here, but the one that is being subtracted. All right, you have first minus second, so we change the second. Okay, now I'm going to go ahead and skip problem C and also a similar one down here at the very bottom that has 3 fractions as well. Not saying that those are bad or anything, but they're just not overly important when you got 3 fractions. If you can subtract 2, you should be fine moving forward here. So you can go ahead and put skip next to those problems there. You don't need to learn those for the exam or anything like that. What I do want you to do right now, though, is please try problems 1 and 2, all right? And then when you're done trying those, as usual, hit the play button. We'll look at the answers. Okay, let's take a look at number 1 here. Based on the fact that I factored the denominators, that as you can see here, using the Berry method on both of those, what would the LCD be? Well, you can see that there's 3 different red ones there. And so those 3 red ones go into the answer, and there's your LCD up there at the top of the screen, all right, based on what you see there for the denominators. So based on that now, what do I got to multiply by in order to transform both of these fractions into the LCD? Well, you can see here that in both of the current denominators, 2 out of the 3 red ones in the LCD are already sitting there. So once again, as I talked about a few minutes ago, if you just multiply by the missing one, you'll be good. And you can see that I did that here. The missing one here was x plus 3 as far as what's in the LCD. And then the missing one here was x plus 2. And then in each one of the denominators, you'll then have the same 3 red ones you have in the LCD. And so that would give me this denominator right here, the LCD on both of these. Both of them are the LCD now, okay? Because you multiply by the appropriate thing. How did I get these numerators that you see right here? I got them because, remember, if you got 2 terms in your numerator, it's as if you're bracketing it. Okay, so I would recommend you put that bracket there to make it easier to not make a mistake when you multiply, but you know it's got to be there, at least in an invisible manner, but I make it visible to make it easier. So that means I need to multiply this out just the same way we did earlier. When you got 2 terms in this bracket times 2 terms in this bracket, you're going to get 4 answers here. I've got those laid out here. Same thing down here, 2 terms times 2 terms in each bracket leads to 4 answers here. And sure enough, that's why both of these have 4 answers. So because we're adding, you guys, you do not do any of that sign changing stuff. You just combine like terms on the numerators, and then the denominator stays the same. And so that leads to this right here. Okay, 7x squared plus 12x minus 12. Again, put it in this order. X squared, x to the first, and then no x at all. Descending order. The reason why I circled this answer, though, is because it's already in lowest terms. I know that because this thing right here is prime. I tried to factor it by doing negative 84 here. And then the middle number was 12. And that nothing works for negative 84 and 12. I know that. Okay, I tried it. And so that's just one big prime one since it didn't factor. And as you can see, nothing's going to cancel here, is it? Okay, so that is problem number 1. That's how you add fractions together. All right. Number 2 is going to, again, since it's a subtraction problem, number 2 is going to be the same thing, except for we have to do that additional step of doing the sign changing that we talked about. So let's take a look at that. Based on my numerators here, my denominators, isn't the LCD going to be, and I don't know if I wrote it down here. Oh, here it is down here. The LCD, you zoom out. Not that much. Hold on. There we go. All right, so the LCD is going to be this down here. All right. Those 3 factors right there. And you can see I have that written there. Okay, and in other words, both of the denominators become equal to this thing down here. So again, because the current denominators have 2 out of the 3 factors from the LCD already sitting in those denominators, you just have to multiply by the missing one. Up here it's x plus 1, and then x minus 1 down here. Once again, we've got 2 terms in a numerator being multiplied by 2 terms and the thing we're multiplying by in blue right here. So once again, you're going to have the 4 answers on each one of these. By the way, let me back up here just so you can see what happened. I did 2 steps in one right here, so that might look a little different than you expected. So I'm just going to redo this. What I wrote down wasn't wrong. It's just I don't want you to get tripped up by what I did there. Multiplying this out, not distributing the negative, but multiplying this out, I get x squared minus x plus 3x minus 3. But you have to change your signs after you multiply, but before you combine like terms, right? So the x squared becomes negative x squared. Then negative x becomes positive x. That positive 3x right there in the middle becomes negative 3x. There we go. and then the minus 3 becomes plus 3. That's why it ends up looking like this. All right, so the thing I erased is actually the same thing as this. I just wanted you to see it step by step there. Okay, so now, since the denominators are the same, I can now subtract the, well, actually, I've already, I can subtract the numerators, but the subtraction process means two things. Number one, to change those signs, which we did, and then number two, to combine like terms. That's the subtraction process, all right? So there's no more subtraction really going on necessarily. It's just combining like terms, because once you change the signs, you just do the combining like terms. That's the two-step process for the entire subtracting of the numerators. That's the two things that you do when you subtract numerators. Okay, so combining like terms, after you change the signs, we get x squared, positive x. All four of these x terms become plus x when you combine them, and then 1 plus 3 gives you the 4. Once again, my numerator, as I try to put this in lowest terms after I get the fraction down here, the numerator is already, it's already fat. In other words, it's prime, because nothing will work for 4 and 1 in the middle there. Nothing works for that. So that's a prime polynomial. The bottom, okay, it does not have any matching red ones to go with the red one on the top, and so that's why I circled this. Okay, there's nothing you can cancel, and so therefore it's already in lowest terms. Okay, there's nothing you can cancel to get it into lower terms. All right. And so that concludes our discussion on adding and subtracting fractions. So we now know how to add, subtract, multiply, and divide fractions. Plenty more to talk about with fractions as the chapter goes along. Okay, but for now, as usual, let me know if you have any concerns about this, and you have a good day.